Solving problems by elimination. There are problems in elimination that actually solve naturally. We call them problems that solve naturally. And these first two solve naturally. And what elimination does is it looks at the x and y values. Everything has to be lined up in order. The order doesn't really matter as long as it's the same order for both top and bottom equation. So here I've got both of these in standard form, x's first, then y's, and then my whole numbers. But what do you notice about these two values, the 4x and the negative 4x? They're opposites, right? So they're opposites, which makes this really nice. I'm going to take the sum of both of these equations. Now, to do elimination, and for it to work, something has to cancel. And in this problem, the x's cancel naturally. So those guys cancel, and I get 9 minus 2, that's going to be 7y, and 23 minus 30, that's negative 7, I think. Yeah? And now I just have to solve for that y, which is super simple now. Divide by 7, y equals negative 1. Now we're never completely out of the substitution thing. Never ever. Elimination still involves some substitution. So now what I do with this negative 1, well, that was easy to get, wasn't it? Now that I get this negative 1, all I have to do is substitute it back into either of these two original equations. I'm going to choose the bottom one because the x is positive. Now I've canceled the x, but it's not canceled anymore when I sub back in. So I've got to sub this back in, so I get 4x minus 2 times negative 1 equals negative 30. Excuse me. So I'm subbing that value back in for y. So this is 4x plus 2. The negative times the negative is a positive. And if I subtract 2, I get 4x equals negative 32. I'm running out of space here, but I'm almost done. If I divide both sides of this by 4, sorry, there we go. If I divide both sides of this by 4, I get x equals 4 times what is negative 32? I think it's 7, 8. Yeah, negative 8, right? So what does this answer mean? What have we been doing all along here with substitution? And sometimes we lose sight of what that is. Remember, what I have here is two lines that are crossing. So what my answer is where the two lines cross. So that would be at the point negative 8, negative 1. It's the solution that matches for both. Okay. Let's look at 2. Zoom out just a tad there. Everybody with me? Yeah? Okay. So on number 2, again, I want to check, are they in the same order? First I've got x's, then I've got y's, then equals, and then whole numbers. So I think we're good. Is anything going to cancel naturally? Yeah, the y's are going to cancel. So if I take my sum, my y's cancel, and I get 9x. Oh, but something else happens. I get a 0. Negative 27 plus 27 is 0. That's what I get here, but I don't need to write the 0. But here I do, because I've got nothing else to show there. Now, we had a problem like this the other day, and I had a number of students kind of get stuck on it, where something, I think it was something like 11d equaled 0, something along those lines. Am I done? Is there a problem with this? Or can x be 0? Well, can it? Can x be 0? Sure. Yeah, it's totally acceptable. So if I divide by 9 here, I'm going to get 0, or you just say, okay, well, 9 times 0 is that. And that's cool because that makes that easy to plug in. Now I can plug it in either to the top or the bottom. Doesn't matter, you pick. Well, I'll pick for you this time. I'm going to put it into the top. No reason other than, so then that cancels that guy out, and I get 9y equals negative 27. If I divide by 9, y equals negative 3. So the point where these two lines cross is at 0, negative 3. Yeah, Hannah. What do you mean, what about the x's? Well, when I did the sum, the x's didn't cancel because I'm adding these two equations together, but the y's did because they were opposites. So I'm not sure that I understand your question. Did I make a mistake? No? Okay. All right. Maybe Juliet can clear her up there on that. All right. Well, so as you can imagine, they're not always that easy. A lot of the elimination's nice and simple, but sometimes you run into a problem like this, where my x's and my y's and my equals and my whole numbers, they're all in order all right, but nothing cancels naturally. So we're going to have to do something. And this one's, actually, let's look at number 4 first, and we'll come back to number 3. Same thing, nothing cancels naturally. I need to wake Nathan up. Nathan. Wake up, man, you're missing it. What? You're missing it. Sorry. We're just about to show you the most amazing thing in math you've ever seen in your entire life, and you're about to sleep through it.
Oh, I didn't think so.
I'm hoping that's true. All right, so what I have to do is I have to actually change something. Marley, all finished? If you'll put it on my chair, right on my chair. I can't mess it that way. So, remember when we were fraction busting, we could either multiply or divide through by the same number? We could multiply or divide through by anything, as long as we did everything. So I'm going to choose to change the x's so that they're opposites. I've got one positive and one negative, and all I would have to do in this case would be to multiply everything on top by 7. So that's going to distribute to everything. So that's going to give me negative 7x plus 21y equals 7. And now I'm going to rewrite this guy. I'm just going to bring it over. I don't have to make any change there. So now what I have is I have something that will cancel when I take my sum. The x's will cancel here. Right? So I had to make a change, but it's not a major change. So now these guys will cancel. And I get, let's see, 21 minus 5, that's going to be 16y. And 7 minus 23, that's also going to be a 16, but it's going to be a negative 16. And so if I divide, I get negative 1. Now, I can take that negative 1 and I can do a few things with it. I can plug it in here, or here, or here, or, well, that's the same thing. I can put it into any of those whichever one looks friendliest, that's the one I want to do. I don't know that I see one that looks friendlier than others, but yeah, that's what I was going to go. Just going to go right into there. Yeah? Okay. So if I go 7x minus 5 times negative 1 equals negative 23, well, these are going to change to a positive, so I get 7x plus 5 equals negative 23. Subtract 5 from both sides. And that's going to be, you've got to add those guys, negative 28. Divide by 7. So that gives me a negative 4, negative 1 for the point where those two cross. So this is more like a normal elimination problem where you have to do something before you get it all started. And what we had to do here is we had to multiply by 7 so something would cancel. I could have gotten the y's to cancel too, but I would have had to multiply both the top and the bottom. Now let's go back to 3 here. So I've got a positive x and a negative x, a positive y and a negative y. So, but I don't have, I can't just multiply a top or a bottom to make this work. I'm going to have to multiply both the top and the bottom. So it's kind of like finding a common denominator. You want to do the x's or do you want to do the y's? It doesn't matter to me. We can cancel either one. Any preference? Anybody want to choose? X? All right, X it is. Thank you. So what would a common denominator be? What's a number that both 5 and 2 would divide evenly into? 10, right. So let's make them both 10s. So I'm going to have to multiply the top by 2 and the bottom by 5. Now the good thing is they've already got a plus and a minus, so that's a good thing. So if I multiply the top by 2, this is going to become 10x plus 6y equals negative 40, right? Everything doubles. And if I multiply the bottom by 5, this is going to become negative 10x, negative 10y equals, let's see, 5 times 8 is positive 40. Oh, that's kind of nice. Looks like I'm going to have a 0. So now my x's will cancel. It's more like a y there. And so I get 6 minus 10, that's negative 4y, and 40, negative 40 plus 40 is 0, so y equals 0. And now I can take that 0 back and I can plug it into, I'd plug it into one of the original equations. Either this one or this one. So what if I put it in, I'm going to put it in the top. Got more positives there. So 5x plus 3 times 0 equals negative 20. So 5x equals negative 20. What does x equal? Negative 4, good. So the point that these guys cross is negative 4, 0. I don't know, what do you think? You like that better than substitution? I do. I like elimination. I find that most students tend to favor this over substitution. Let's see if the back has a hard one. I don't see a really hard one, any harder than what we just did. But let's look at number 10, and maybe number 9. For number 9, they're asking us which way would be best to solve it, elimination or substitution. I would say elimination because you have your x's and your y's and your equals and your whole numbers. They're all in the same order. So I would use elimination here, but look at number 10. To use elimination here, you're going to have to do some rearrangement. And so in this case, since we already know what y is, this would be a good one for substitution. So there's reason to know both methods, substitution and elimination. I'd use sub here. You take that, you're going to plug it in there. This one, elimination. So we still want to use substitution when it makes sense. All right. So let me give you the problems, and I'm going to look and see if there's a hard one on today's problem set. Looks to me like the hard ones are coming up tomorrow. But when I say the hard ones, it's not that hard. Yeah, no, I think these are set up for you to do a fairly easy elimination. So give these a try. I'll come around and help out once I take roll, and we'll be good to go.